Hi, we are at CES 2019. People always have a lot of interest in our two-phase liquid immersion cooling system. As you can see behind me, today we are going to take a closer look and take you through exactly what this is. So why do we call it a two-phase? We submerge the server into the CO tank, which is filled with 3M Novak engineered fluid, and the heat transfer by evaporation and condensation, and therefore we call it a two-phase. The fluid is not water, it is the electric chemical fluid made by 3M, which is non-conductive and non-corrosive, and only has a constant boiling temperature of 56 degrees. The fluid comes into contact with the CPU and GPU chip, boils and evaporates into vapor. In the rear of the unit is a cooling condenser coil. The vapor will then condense on the coil and rinse back to the fluid base. Through this process of evaporation and condensation, the heat from the components is dissipated. Looking from the side, you can see this unit is totally compatible with our 2U high server. We replaced the CPU and GPU heatsinks with a thin copper foil that is more suitable for heat transfer in liquid. Also increased the capacity to accommodate 16 full-high full-length accelerators, which is double the previous generation. Since the fluid is non-conductive and non-corrosive, no special wires or plugs need to be installed, which makes the system really to the point. You can see the handles on both sides of the system that allows this to be easily pulled out for maintenance. Gigabyte is the industry leader in HPCs, and our G291 series is a famous product line in the market, which carries the maximum quantities of accelerators in a 2U box. We see that the CPU and GPUs are getting harder by generation, so we started to figure out an alternative to solve the thermal problem a long time ago. We cooperated with Light Control to launch the first immersion cooling 3 years ago. We gained a lot of experience since to optimize this system, and resulted in it being a lot more efficient at heat dissipation than air, up to 4,000 times more efficient. We're continuously looking for better server solutions for a better future, and it is apparent that liquid cooling is a lot better at moving heat than air. This can allow the CPU and GPU components to operate at temperatures a lot higher than normal air cooling, allowing them to run at greater speeds to achieve better performance while also reducing power consumption and energy bills, since we don't need fans inside the chassis. When these systems are deployed in large numbers, such as in a data center, in some cases, power savings of up to 90% can be achieved compared to air cooling. Another main benefit is density. As mentioned before, no large heat sinks and fans are needed. The components can be placed a lot closer and a lot more can be installed in the same place. We instead installed 16 dual slot accelerators, which is twice the amount in the same space. This density can be very important where space is at premium, such as for edge computing or for a data center in a larger city where rent is very high. We managed to double the computing power of this second generation immersion cooling while also reducing the physical size by twice the original, which fits perfectly with our goal to upgrade your life with technology. Hope you now have a bit more understanding of our immersion cooling and why we call it two-phase. And that's the end of the video. If you liked something like this, please show your support by comment, like, or subscribe to the channel so that we know to make more of these in the future. Thank you, and maybe see you next time.